Our results of the previous video, we are going to now construct the steps to finding the turning point. What are we looking at? The steps to finding the turning point, right? To finding the turning point. Okay. And remember, I'm generalizing this. So these steps are valid for any polynomial. It's valid for any polynomial function. You've done it using a shortcut for the parabola. Okay. So remember, the first step was to find the derivative. Okay. So I'm going to list that. Step 1 is find dy by dx, which is the derivative. Then what was step 2, Ahad? After you found the derivative, what did we do? We made it equal to 0. Very good. Step 2 is we make dy by dx equal to 0. Step 3 is what? Solve for x coordinate. Now, why did we make it equal to 0? Because we know that at the turning point, what equals 0? The gradient, which is also known as the slope, but also known as, we learned a very fancy word in calculus for the slope or the gradient. The derivative, people. Okay. And then what did we do with step number 4? What's this? We substitute x into f of x, right? You don't put it in the derivative, you put it into f of x, you put it into the original function. Okay, so I'm going to start with example 1, and we're going to do this on the 5 functions that we learned. Okay, so I'll give you a moment to write that down. You can pause the video here. Okay, so going back to your table, remember when we started this section you were required to draw out a table, and you had 5 graphs on there. Remember, I don't have the table any longer, but I've got the curves from the table. So the first graph was y equals x cubed plus 6x squared. I just want you to refresh my memory on some of the information. The x-intercepts here were what? What were the x-intercepts? Right. Right. Negative 6 and 0. Okay, and the y-intercept was? Okay, so this was a very interesting one. There's a lot of zeros involved here. Okay, I'm just going to change the color of the y-intercept. 0 and 0. Okay, now guys, let's find the turning point, because that's what we're looking for next. We're looking for the turning points, right? Now there are 4 steps, and I'm sure you've written them down. You've engraved the neural pattern. X cubed plus 6x squared, x cubed plus 6x squared. That's my curve. What's step number 1? Find the, and since it's a polynomial, we use what rule? The power rule, right? So can anybody give me the derivative over here? Very good. 3x squared, right? Plus 12x. Okay. Okay. What is step number 2? So I'm going to put the 0 in the derivative section, and then I say equal to 3x squared plus 12x. Are you guys with me? Okay. And how do I solve this? The rest is normal algebra. How do I solve this?
Solve x.
Yeah, how do I do it? That's step 3, right? How do I do it? Factorize. So what's the common factor here? 3x into 4, right? And that results in 2 things. Therefore, x is equal to what? Come? X equals 0, that's from this factor here, or x equals negative 4. Okay, so now I need to take each of those and I need to substitute it back in. Remember, this was step 1, this is step 2, this is me solving for x, which is step number 3, and now step 4, which I'm going to put on this side. Okay. Step 4 is to substitute each of that x values in. So you remember we got two x coordinates now, and the reason we have two x coordinates is because how many turning points are there for a cubic graph? 2, right? Very good. Okay, so let's substitute in x equals 0. When I put in y equals 0 cubed plus 6 times 0, oh mama, sorry, that was an error, 0 squared, and this gives me 0 plus 0, which is just 0. And when I state that as coordinates, use sky blue for now, I've got 0 on x, and I've also got 0 on y. Now, for the next part, let's do the next one. Y is equal to negative 4 cubed, are you guys with me? Plus 6 times 4 squared. Okay, you can do that one on a calculator quickly. This is going to give you negative 64, isn't it? Right? And that's 16 times 6. What does that give you? 96. Yes, no? Okay. You could have said this is f of negative 4 or... Okay. And what's my answer here, people? Minus 64 plus 96. Okay, and then this y value over here was positive. Remember, this needs to be a negative in this one. It's going to be positive 32. And again, if we state that as coordinates, that's going to be negative 4 on the x and positive 32 on the y. Are we good, people? Okay, so there's a message from one of our WhatsApp subscribers, just helping us out with the spelling of infinitesimally. Let's just see what they've said over there. Okay, so it's infinite. That must be an E, right? And that must be an I. Okay. Right, great. Thank you, WhatsApp people. Okay. Okay, so let's get back to this quickly. Now guys, when I list this over here, I've got 0 and 0 as a turning point, and I've got negative 4 and positive 32 as a turning point. When I started this section, I said what we are going to do is we're going to use, this is where the calculus comes in when we look at the turning points. And all we are really interested in doing is actually sketching a cubic graph over here. Okay, now one of the things I want you to note is a relationship, right, which we will show to be true, is if I have two x-intercepts at the same point, then that x-intercepts that duplicate themselves must also be a turning point. And that will always be the case. And you know why that's the case? It's like you cross the x-axis, but you decide to turn around at the same time and cross again. So think about crossing the American-Mexico border. You cross over, you turn around again. It's like having a turning point on the border or on the intercept. Are we good? Okay. So guys, how do we draw this? I'm going to draw this curve right here. Let me just take this away. Okay, let's see, how do we draw this? What was this point? Minus 4 and positive 32, eh? So let's set up a coordinate system. Green, yellow, green. Okay, there's my coordinate system. I'm going to need to extend it a little bit further. Okay. Arrows on the positive portions. Okay. Righto. Now, let's plot these points. Let's put all the x-intercepts in red. One of the x-intercepts was at 0 and 0, right? Another x-intercept was at negative 6 and 0 x-intercepts. Right, so let's just say that's there. Okay. This graph is positive, so its shape must look like that. Okay, where's the y-intercept? The y-intercept was also at 0 and 0. Okay. And the turning points, now let's go put in the turning points as well. I'm going to use this violet for the turning points. I'll make a dot there for my turning point. Okay. The turning points was negative 4 and positive 32. So here's negative 4 because that's negative 6, so negative 4 is here. And positive 32 will, let's just say, somewhere there. Okay, are you guys good? But I'm just going to draw it there so that I'm using two different scales on my x and y. Once you have these turning points and intercepts, all you do is join them and then you have a curve. So how do you join them? That's all you do. Turning point, you turn, right? Remember, you go through the x-intercept, but it's also a turning point, so you turn around again. And then that's my graph. Are we good? Are we good? Okay, don't worry, we're going to get a lot of practice doing the other 4 now, and we'll see how to do that. Okay, so that's example 1 of sketching your cubic curve using everything we've learned over the last 29 videos.